gamma is 95%. In this model, we only conduct the cyclic computation. The mean is changes to outside of this range. Here is some initial experimental evaluation. For this evaluation, we simulate some sensor networks and generate synthetic data with some scenarios. And we carefully manage the parameters to generate some various kind of sensor networks and various situation of the data generation. And goal of this experiment is showing the efficiency and effectiveness of our cyclic framework and comparing the batch mode and the immediate mode. This experiment result shows the computation efficiency of our cyclic framework. The first graph shows the scale in the sensor network, and the second one is the result when we varying the window size. It means that the size of the history data we consider in the framework. And then we can see that this result shows that the computation overhead is affordable and scalability, and has some scalability in both the size of the sensor networks and the size of the history data. And the second experiment results show that effectiveness of the cyclic framework. In this figure, we show two kinds of sensor networks and two kinds of the sensor network and data generation to show the effect of the difference in provenance. And in the first graph, start with the default trust score 0.5. We inject some incorrect data to the sensor network and see what happens in the data trust scores. And after the 20 or 40 cyclic computation, we can see that the data trust score will reflect the injection of the incorrect data. And here we can see that if the data provenance is, if we use the data set with a similar provenance, we can see that it more fastly decrease in the trust score. The reason is that with this principle, we say that if the data value is the different beta value with a similar provenance, decrease the trust score. And then the second figure shows that from the default trust score 0.5, we continuously generate correct data to the sensor network. And here we can also see that the computation will reflect this situation. And here, in contrast to the previous result, we can see that if we use the data items which has different provenance, more will reflect the situation, because we say that the similar data value items, similar data value with the different provenance increase the trust scores. And this result shows that our cyclic framework will reflect the situation, the trust situation of the data in sensor networks, and also our principle, our observation and our principle is will reflect the trust score changes. And the last one is the comparison between the immediate and batch mode. we vary the competence level gamma from 99% and 70%. This means that with the 99%, the cyclic computation is more frequently happens, and less frequently happens, and with the 70%, the computation is more frequently happens. Then obviously with the less frequent computation, compared to the immediate mode, it only takes 30% in computation time. But it still have more than 70% correctness compared to the immediate mode. And it's around the 90% when we use the 70% competence level. From this result, we can see that the advantage of the batch mode is significantly reduced the computation overhead compared to the immediate mode, still have some good accuracy in the computation. Until now, I will show some challenges of this problem and shows our initial solutions for this problem, and then now I will briefly explain about the open research issues related with this topic. There is two kinds of topics. First one is the using data provenance, and the second one is delivering data provenance. And the first issue related with the using data provenance is measuring trustworthiness. In our initial solutions, we use some statistic models and some principles and some observations to measure the trust scores. But there are many research issues related with this topic. First one is data provenance presentation. As I said, it can be a simple path and a tree or a graph. And if we want to also involve some operations, then it becomes more complex. And second, we need to consider the provenance similarity. We simply use the edit distance, but we need to check it is enough. And also, the edit distance between two graphs is known as NP, hard problem. Then we need some approximation and pre-computation to solve this, to overcome this situation. And also, there can be multiple data provenance. It means that until now we only use the ID of the sensor as a provenance, but it can be a GPS location or ID of the vehicle and unit name of the troops and many other things. It means that one data source has multiple provenance, can have multiple ID, and one data has multiple data provenance. And also, data provenance can be changed dynamically. For example, if we consider GPS location as a provenance, probably the provenance can be changed according to the movement of the sensors. And trustworthiness measurement model should be also can be improved. The second issue in using data provenance is combining data provenance with query processing. Usually, data provenance or data itself does not have much meaning, but if we can use it, only it has some meaning when we use it for some decision making or filtering some useful information. In this case, we need to improve the performance of the query processing with the combining data provenance processing. And the second one is the we also think about improving the trustworthiness with the result, with the trust scores of the data items. It means that if we can during the query processing, if the target data does not have enough trust scores, then probably we can need to something to improve the trustworthiness of the data. probably it can include some adding more sensors or increasing sensing rate